Lewis Dodd. Carbon, when it has 4 identical things around it, nonpolar always. This gives you power. CF4, nonpolar. CCl4, nonpolar. CH4, nonpolar. Okay, so tell me my answer here.
Is it because of even number 3?
Okay, which is our answer for number 4? B. Everybody good with that? Okay, don't just write this down. Get an idea how this is done. All right, onward. Okay. Based on the figure above, the boiling point of ethyl alcohol under an external pressure of this many atmospheres is what? Okay, so it's interpretation of the plot. Now notice we have temperature, that's what we're controlling, and that's our independent variable. Our dependent variable is vapor pressure. Now, you could have a chart like this and have a whole bunch of different kinds of questions here. What we have, we've got water, and then this one here is our ethyl alcohol, and this is diethyl ether. So be sure you've got your labeling to go with the correct line. Of those 3, think of vapor pressure only. Vapor pressure only. Don't worry about this problem yet. Of these 3, which has the strongest intermolecular force of attraction? The ether, the alcohol, or the water? Water. Okay, because it has the lowest vapor pressure at any temperature. Any temperature you take, if we take 20, which is about room 10, it's got the lowest. The thing with the strongest attraction will have the lowest vapor pressure. Okay, so of course, which one has the weakest intermolecular force of attraction? The first one, the diethyl ether. Okay, now, we got to take that a step beyond. Remember boiling point, the way a scientist defines a boiling point? When the vapor pressure is equal to external pressure. Now, we talk about normal boiling point. That's when it's a normal day at sea level and atmospheric pressure is 1 atmosphere or 760 torr. That's why when people say, what's the boiling point of water? They really should say, what's the normal boiling point of water? Okay, so here, we're at this in atmospheres. Now, we look over here and we go, oh no, that's in torr. So in order to read this graph, we're going to have to change this atmosphere to torr. Okay, so 1 atmosphere is how many torr? 760. Tell me how many torr we have.
Let's do 40.
Okay, what was the number? 55. Good. 55 torr. So you can just take 0.0724 times 760. Everybody good with that? All right, now 55 here. Well, right about there would be 100. So let's go down about halfway down there. And which compound do they want? Ethyl alcohol. So come out and across. At what temperature will it boil?
20 degrees
20.
Celsius.
20 Celsius. Is everybody good with that interpretation? See, something like this, you could have all kinds of questions. You know, what's the boiling point when the pressure is this, or this, or this? And they could take any one of those liquids. Or they could ask you about attraction for one of them. Who has the highest? Who has the lowest intermolecular force of attraction? Okay, we good? All right. Next. We have, by the way, just moved into chapter 12 now. But I predict each chapter will start going a little faster when your memory gets to be in more, not in your distant memory. Okay, which of the following compounds will be most soluble in ethanol? Okay, remember that old thing, likes dissolve likes. Okay, so ethanol, or ethyl alcohol, whichever, either name. That, what kind of compound is it? Is it ionic or is it covalent? Covalent for sure. Then, is it polar or is it non-polar? It's polar because of that OH group hanging out at the side. Okay, now, likes dissolve likes. Look down through here. If we want it to dissolve, it better be another polar substance. Okay? Now, hexane. Would it dissolve in hexane? No, because we know hexane is non-polar, it's a hydrocarbon. Okay, trimethylamine. Now that's going to be kind of similar. It would be similar to this. Okay, we do have the lone pair there, but we also have a lot of organic groups. Now, if it's trimethylamine, it'll only have one C, one carbon here, so it would be a little bit smaller. So that's kind of still in the running. Let's not discard that one yet.
It's non-polar.
It's polar. It's polar because, here, let me clean this up. It's still slightly polar, but we might find a better one, so let's not pick it yet. Okay, I come down here to acetone. Okay, if I do a Lewis dot on acetone, these are the hydrogens out around. Acetone, okay, this part of the molecule is going to be slightly polar. So my last two, okay, kind of polar, they're still both in the running. Okay, now let's go down here. Ethylene glycol. I have an OH group at one end, I have an OH group at the other end. So we want to pick our best answer. Which of the following compounds will be most soluble? Which one would you go for? Which is most similar to that compound? It's going to be D as in dog. Because you got OH, you got OH. Now, I would bet it might be a little soluble in B, it might be a little soluble in C, but your best bet is the one that's most similar. Okay, now we get to numbers here. On number 7. Okay, let's read over. How many moles of KF are contained in 347 grams of water in a 0.175 small m? What does small m stand for? Molality, not molarity, molality. KF solution. Okay, your big clue that you see in there is this small m for molality. As soon as you see the big clue, and there's really just one big clue in this thing, is the molality. What's my definition here? It's just memorization. What goes in the numerator? Huh?
Grams.
Uh-huh. Okay, in the numerator. I hear grams, I hear kilograms, and I hear moles.
Let's go with the mole.
Let's go with the moles. Moles of what? Solute. Divided by what kind of units? Grams? Kilograms. Flashcards.
Can we have one?
No. You can to study, not for the test. Okay, now, just because we were on shaky ground there, and I don't know if that's, I don't know if these definitions are on the back. Amy, take a shot and see if you see this. Okay.
I don't think it happened.
Could you find any concentration definitions there? I don't think they're there.
No, because I remember.
Okay, let's look up here. Let's jog the memory here. Molarity. Molarity's over there, and that's what this problem's about. In the numerator, what is it?
Moles over liters.
Very good. Moles of what? Solute. Over liters of what? Of solution. Total thing. Okay. The reason why we are plagued with this equation in one chapter is because that concentration is temperature independent. And that's what we use for freezing point depression and boiling point elevation. Okay, whereas this is slightly temperature dependent because you have a volume, and volumes of liquids can swell or whatever with temperature changes, swell or shrink. Now, percent concentration by mass of a solution. By mass, what goes up here? Grams of solute over grams of solution, total, times 100 because it's percent. If you think mathematically and stay calm, you could figure this one out. Percent, part of the whole. By mass, so grams. Okay, now, mole fraction. They usually do mole fraction for the solute, so it would be moles of solute over, and if you think mathematically, you could crack this code too. That you want the mole fraction. What part? So you want to say moles solute plus moles solvent. Do not tell me moles of solution. It's got to be the two, because the solution doesn't have a molar mass of its own. Okay, now let's get back to this one. Okay. Oh, they made this one really pretty easy for you. They always have to give you 2 out of 3, because you got 3 variables here. So they have told us molality, 0.175. Okay, now, yes, they gave us some bad units. Of course, water we assume is what, the solute or the solvent?
Solvent.
Solvent. And the word there is in, the magic word. So, if I have 347 grams, how many kilograms do I have? 0.347 kilograms. So, all we got to do is solve for that.
When I first did this, I did the molarity.
Molarity?
Yes, ma'am.
How'd you get that done?
Well, 1 gram equals 1 liter of water.
Yeah, but
1
your
kilogram
definition,
equals 1 liter of water. Well, that's what I'm asking. It's just a difference in definition.
it's, okay. You really couldn't do that unless I gave you density on this one. Because you can't get at liters of solution. You can get at liters of solvent.
Yeah, that's what I did.
That's no good.
Okay,
Not
so
good
it's just
enough.
the definition that throws you off.
Yeah, exactly. Do you see how you'd have to have more information on this particular one to go to here? Because you can get liters of solvent. Now that's going to be close, to liters of solution. But that KF is going to take up a little bit of space, so technically they're not going to be quite the same. Okay, so we come over here, and how many 6 do we need in that answer? 3. And did they, yeah, they held us to it. Okay, does anybody punch that?
Hey,
It's A, as in apple? Okay, Everybody good with that? I can look at my key here if I need to. Okay, onward then. Let me just ask you a question. How could I change this up to make it a little more challenging? If it said how many grams of this stuff, you could do that, right? You get moles. From here, you get moles. But if you have moles, remember this. Okay, if I had grams and I wanted moles, what do I do with the molar mass? Divide. If I have moles and I want to go back to grams, I multiply by the molar mass. So if it gives you, if they ask for moles, you go, thank you very much, I don't have to go any further. Okay, good. So this means need to know definition of various concentrations. Look here, number 8. How much water, this has a nice little twist to it, must be added to 40 grams of calcium chloride to produce a solution that's 35%, and you can assume it's by mass. It doesn't have those words in here, it really should. So by mass of calcium chloride. Okay, so the big clue in there is percentage. Okay, is percentage. So we come over here.
It's not voting.
It's not what?
It's not voting.
No, it's not. The only people that use percent volume are people making beer and wine. That's not us, at least at school. Okay, so how much water must be added? So here's our thing right here. Okay, let's see what they've given us. We really have 1, 2, 3 variables, but there's a dirty trick built into this thing. Okay, percent, we have 35.0%. We have 100 over here. Leave the 100 in. And here's the speech I made before when we were doing this long, long ago. You probably get conditioned. If you see a percentage, you move that decimal 2 places over and go with it. Okay, if you do that, then you got to leave the 100 off on the other side. So if you see that big clue, you write this down immediately, and then you sort through your problem. What are they giving you? Well, they're giving you percent. If this 100's there, leave it. Leave it. Now, they tell us we have 40 grams of calcium chloride. Is that the solute or the solvent? Solute. Okay, so we put 40 up here. Okay. Why can't I just stick X down here? Well, we need grams of solution. Now, there's a couple of different ways to do this. Here's what I would recommend. This is total solution. Okay, I want the water. X, the way I just said it, would not be the water. But I can say 40 plus X, and I can get at the water direct. Okay? Now, I could see you doing it an alternative way. If you understand this, go with it and don't listen for the next sentence. You could just call this X, but realize when you get X, you got to subtract 40 out of it before you answer the question. Okay, so here, it's just a nice little algebra problem. What I would do is I treat this as a unit. First, probably what I do, I take my 100 and get rid of it. Okay, so now it looks like this. Can everybody see that low? Okay. Now, here's what I would do. I would multiply both sides through by this entire thing. So I would have 0.35 times 40 plus X is equal to 40. And then just methodically go through the algebra.
Where's the 100 again?
We
took away
I divided both sides by 100, or moved it over to here.
Oh, okay.
See, I was doing it, moving my stuff stepwise. So first, I moved the 100 across, and then I moved this whole thing across to get rid of my fractions, and then I just multiplied this, and I got 0.35x is equal to 40. And does anybody have an answer for that?
34.28.
Okay, which must be D as in dog. Did anybody else punch that to know it? Okay, good deal. Are we all right on that one? Okay. What is the mole fraction of I2 in a solution made by dissolving 55.6 grams of I2 in this much hexane? And it gives you the formula. Okay, what's the big clue? What's the big clue? Mole fraction. Okay, so we know this, that is what we need. Okay, so after I decide what it is I need, I'm solving for, okay, over here, separate from the problem. I think just to make the math as easy and not have complex fractions, I would say I have 55.6 grams I2. And I want to switch that to moles. Okay, here's this problem. I got grams, I need moles. What do I do with the molar mass? Divide. So let's look over there for iodine. And iodine is